In this segment, we'll talk about some prior knowledge which you need from your previous classes, such as statistics and probability, about some simple statistics. So these simple statistics which we're talking about are simply average, total sum of squares, variance, and standard deviation. So let's suppose you're given n data points, y1 all the way up through yn. Then the average is defined by this, which is simply adding all the y values and dividing by n, which is the number of points which are given to you. Then we have the total sum of squares, and that's why it's ST, S standing for sum, and T standing for total, which is simply the difference between the observed values of y and the average value of y. So you square each quantity and then you add them up. So what you're basically going to do is that sometimes this is also called sum of squares total, but we should also call ST to be better, call it sum of squares of difference between observed and mean value. The reason why we say that is because when we go into regression, we'll be calculating another sum of squares, and so we want to be able to differentiate between the two. We'll talk about that later, but so we call this sum of the squares of the difference between the observed values and the mean value. Then we calculate the variance, which is sort of an average value of the total sum of squares, and we divide by n minus 1. Now somebody might say, hey, why do we divide by n minus 1? It's because we are calculating the sample variance and not the population variance. And that's going to create a little bit of bias because we have only a certain number of points which we are taking from the population. And because of that, we have to apply a correction so that it leads to a more accurate answer than by using, let's suppose, the value of n. Now somebody might say, why is it n minus 1? Why not n? Why not n minus 2 or n minus 3? It's all been found out that if you look at other sources called the Bessel's correction, that hey, this is the best value to use in the denominator to get rid of as much bias as possible. And then we have the standard deviation, and the standard deviation is simply the square root of the variance, and it basically gives it the same units or same what we can call as order as that of the average value. So that's the standard deviation which you have there. And let's go and look at these numbers through an example. So here we're given some numbers. We want to be able to find out what the value of the average total sum of squares is, variance is, and standard deviation is. So your y bar will be equal to summation y sub I of all the points divided by n. So in this case it will be 5 plus 8 plus 50 plus 3 plus 7 divided by 5, and that number turns out to be 14.6. Now let's go and calculate the total sum of the squares. As I said, that we should call it the sum of the squares of the difference between the observed value and the average value. So that is defined as this. So if we just calculate the average value, so that's going to go here. So we have the observed value, so it'll be 5 minus 14.6 squared, and we'll keep on doing this. So we have written down the 5 differences, and that's what we're going to is 1581.2. The next one which you have to calculate is the variance, which is sigma, which is denoted by sigma squared. That is nothing but the total sum of the squares divided by n minus 1. So we have 1581.2, and since we have 5 data points, we 5 minus 1, and the value which you get is 395.3. And the last quantity which you have to calculate is simply the standard deviation, which is the square root of the positive square root of sigma squared, which is the variance. So there will be square root of 395.3, and this number here turns out to be 19.88. So when we go to regression, you will see that why we have to review our simple statistics from our previous course to be able to do that. And that is the end of this segment.